Good morning, everyone. Hope my voice is audible to all. Let me clarify whether my voice is audible. Okay, fine. If it is audible, let me commence the session. Today, we are going to discuss on the chapter carbon and its compounds. We all know that carbon is most essential element and it is an non-metal, and easily it can form a bond with hydrogen to form hydrocarbons, and they have very unique properties. And before entering into knowing the properties, so on the earth crust, carbon will obtain in 0.02% in the form of carbonates, hydrocarbonates, coal and petroleum. These are the some of the forms where the carbon obtained. And what is the percent? It is about 0.02% on the earth crust. This may ask for your exam. What is the percentage of carbon obtained on the earth crust? It is 0.02%. And in the atmosphere, it has 0.03%, and it is obtained in a form called carbon dioxide. Now, don't get confused. The question is very clear. The percentage of carbon on the earth crust is 0.02%. The percentage of carbon in the atmosphere is 0.03%. And what are the different forms? Carbon on the earth crust, it is obtained in the form of carbonates, hydrocarbonates and petroleum products. And in the atmosphere, it is obtained as carbon dioxide. Hope I think these points are clear. Yeah, good morning all. Okay, now whether it is clear how the carbon exists on the earth crust and in the atmosphere. Is that clear? Okay, fine. Okay, fine. Good. And I think voice is clear even with cloudy environment. Okay, now let me go with the properties. Now, in order to know the properties, I just share the carbon is abundant in nature. They form very strong covalent bonds. Each carbon has 4 valence electrons, so that it can form 4 single bonds with other mono elements. They have variety of shapes and they can form the bond with multiple elements. So simultaneously it can form bond with hydrogen and also chlorine with 4 elements, because chlorine and hydrogen are the mono elements. And which are the different chemical reactions where the carbon involved? They undergo combustion reaction They undergo oxidation reaction, addition reaction, and substitution reaction. I'll repeat, these are the 4 very important chemical reactions where the carbon and its compound is easily involved. That is combustion, oxidation, addition, and substitution reaction. And carbon usually have the ability to form the bonds with oxygen, hydrogen, nitrogen, phosphorus, and sulfur. As a result, they can form biochemical compounds which are very essential for life activities. Example, glucose. It is most important for all living organisms for their survival and to get the energy. And what is the molecular formula for glucose? C6H12O6. Right? So, like this, carbon forms a biochemical compounds which are very essential for life activities. Carbon has exceptional ability to form the bonds with more elements, and usually they form covalent bonds to form highly stable compounds. Once if it form the covalent bond with the monovalent elements, they become highly stable. They form a stable compounds. Carbon is an 6th element and it has got the atomic number 6. It is located between boron and nitrogen. It is highly stable compound. Stable in the sense they are less reactive. And they exist in different forms in the nature, in a gaseous state, in the solid state. And they have a unique property, that is allotropy. They show allotropy. Allotropy in the sense different physical properties. Any compound element showing different physical properties, but they have same chemical properties. I repeat, carbon shows allotropy. Allotropy in the sense the element showing same chemical properties but different physical properties. Example, the carbon, the different sources are diamond, graphite, and amorphous. Diamond is the hardest carbon compound. Graphite is so smooth, easily it can be broken within your hand when you handle it. And even carbon can exist in amorphous state, that is in a powder form. So such a versatile compound is carbon. Before entering into the clear properties of the carbon, let me have some more examples other than carbon. This is the example of hydrogen. Hydrogen molecule H2 And how it is formed? Hydrogen has one valence electron. You can observe X. X indicates valence electrons. And it requires one more electron to form a complete orbit. So it requires one more electron. So it tries to bond with another hydrogen which is having one valence electron. You look at two hydrogen atoms with one X on each side. When it combines, both the X together bound together, and that bonding is known as covalent bond. The bond between the hydrogen molecule is called covalent bond because covalent bond forms by sharing the electron. Both the hydrogens, they share the electron by forming covalent bond so that they will attain that outer orbit is completely filled. The one more example for covalent bond is oxygen molecule O2. You can observe the oxygen. The valence electrons are 6 and oxygen atoms, you can observe 6x are written around the oxygen atom. And how many it requires to fill as an octet structure? It requires 2. So you can observe the down diagram. Oxygen 6 with 2 merges to form 8 octet electrons in the outermost orbit. So you can observe that 2 electrons shared between the oxygen atoms. 2 electrons, pair of electrons. Hence, the bond formed is double bond. In the hydrogen, it is only one electron being shared and single bond is formed. But here, 2 electrons are shared so that it forms double bond. O double bond O. This is the covalent bond in oxygen molecule. And this is one more example, that is nitrogen. You just observe the nitrogen has 5x, and that is 5 are the valence electrons of the nitrogen. So how many require to complete as an octet structure? It requires another 3 electrons. 5 plus 3 is 8, right? So now you can observe the circle. Now the 3 electrons share with another 3 electrons of nitrogen atom so that it attain octet structure. Now what is the bond? It is triple bond, as 3 electrons share to complete the octet structure, hence it forms triple bond. Yeah, now we just had a deep discussion on covalent bonds. Covalent bonds are formed by sharing the electron. Now, any one of you can give example which were the different elements just we studied which form covalent bonds. Just now we discussed, you can give same example too. You can give example, not the structure, okay? Where you come across covalent bonds, give example. Just now we discussed. Yeah, Arshita, fine, good. Oxygen molecule, hydrogen molecule. Yes, good, Priyanka. Here also, hydrogen molecule, oxygen molecule, and nitrogen molecule. Okay, the difference is oxygen, it's not clear whether it is an atom or molecule. Okay, you are supposed to give as hydrogen, oxygen, nitrogen molecule. Then it will be very clear. Okay, perfect answer. Yeah, good, Sandhya, Arpita, even Nandita, good. Okay, fine. Who is under name Guru Prasanna? Yeah, Deepa, correct? No, Harshita, it is not compulsory that hydrogen plus oxygen is covalent bond. Not in that way. The covalent bond is just sharing of the electron. Now hydrogen atoms share between them to form hydrogen molecule. Oxygen atoms share the electrons to form oxygen molecule. Nitrogen atoms share the electrons to form nitrogen molecule. Carbon and hydrogen share the electrons to form hydrocarbon. All these are the covalent bonds. Okay. Yes. Now it's correct, Priyanka. Okay. Now we'll move on. Okay, let me clarify. Okay, Tanushri, okay, fine. Now let me clarify. When I share the screen, is there any disturb in my voice? Okay, fine. Okay, now we'll move on to the concept. Saturated and unsaturated carbon compounds. And before that, I'll share the screen. Okay, fine. Today it's okay. No problem with network. Even with the rainy, cloudy day, we have very clear network. Thanks for that. Okay, we'll move on to the next concept. Okay, now let me study hydrocarbons. What are hydrocarbons? The compound of carbon and hydrogen is called hydrocarbon. The compound of carbon and hydrogen is called hydrocarbons. Hydrocarbons can easily differentiate it between saturated and unsaturated carbon. How we can differentiate saturated and unsaturated carbon compounds or hydrocarbon compounds? It is very simple, by bonds. Saturated hydrocarbons has only single bond, whereas unsaturated hydrocarbons has double and triple bond. And this is the example for saturated hydrocarbon, because the carbon with 4 valence electrons share the electron with hydrogen atom with 4 hydrogen atom, because carbon has 4 valence electrons. Hence it is called tetravalent compound. Carbon compound shows tetravalency because they have 4 valence electrons which can form 4 bonds with other 4 monovalent elements. I'll repeat. Carbon shows tetravalency as it has got 4 valence electrons and it has got the capacity to form 4 bonds with other 4 monovalent elements. Now, which are the monovalent elements? Oxygen, chlorine, right, etc. And the question may ask, what is tetravalency? And even they may ask, give example how the carbon shows the property called tetravalency. These are the 2 ways the question may ask on tetravalency. Very simple, the answer is so simple. Carbon shows tetravalency because it has got 4 valence electrons in the outermost orbit. In order to attain octet structure, they form 4 bonds with other monovalent elements to reach octet structure. And this property is known as tetravalency. The example is methane. Now, as you all seeing the picture, this is methane. CH4. CH4 is the molecular formula. New Jersey indoor gardening, so glad to see you on the live show. I'm so happy after a long gap. I'm just having a view of your name. Thank you so much for the visit. Thank you. Thanks a lot. Okay, now we were discussing about saturated and unsaturated carbon compounds, and I gave the example for saturated hydrocarbon, that is methane. And even we were discussing about the unique property called tetravalency, how the carbon element show tetravalency. It has got 4 valence electrons in outermost orbit, hence it can combine with 4 monovalent elements to form 4 covalent bonds, right? Kitty, so late? Okay, now why the saturated hydrocarbons are inactive, less reactive? Even this is most frequently asked question in your examination. Just now we come to know what are saturated hydrocarbons. The hydrocarbons with single bond is known as saturated hydrocarbons. And now next question is why they are less reactive. It's okay. I gave the timing but still late. Okay, I didn't get answer from you all. Saturated hydrocarbons are the compounds with single bond, right? And they are considered to be less reactive, highly stable, less reactive and highly stable. Why it is called so? Okay, I didn't get any reply. Okay, I'll reveal the answer. The saturated hydrocarbons are highly stable and less reactive because the carbon forms a single bond with other monovalent element, and there is no scope to combine with other elements. There is no scope, there is no place for the carbon to make a bond with other element. It is completely filled, and hence they are considered to be highly stable and less reactive. There is no chance for the other element to combine with saturated hydrocarbons. Hence it is called they are highly stable and less reactive. There is no chance to undergo addition reaction. There is no chance to undergo addition reaction. Okay, cleared? What may repeat? Why saturated carbon are called less reactive? Should I repeat or shall we move on? Okay, I'll repeat. Now, hydrocarbons are differentiated as saturated and unsaturated. Saturated compounds are highly stable because they are formed by single bond and easily they cannot be broken down, and again it cannot give chance for other element to combine with it, because double bond and triple bond can be easily broken down by addition reaction, but saturated hydrocarbons cannot undergo addition reaction. Hence, they are less reactive. Saturated hydrocarbons are less reactive because they are formed by single bond and that cannot be easily broken down. And hence very less chance to combine with other elements. Hence they are less reactive. Highly stable compounds. Okay, Cleared? Okay, Tanushree only having the problem with my voice. And rest of the people, I think they can hear me today very clearly, right? Okay, fine. Saturated easily cannot be broken down, and hence they cannot combine with other elements as it is made up of single bond. Hence it is highly stable. Okay. Okay, now I'll share the screen. So these are saturated hydrocarbon because it is made up of single bond. And this is another example for saturated hydrocarbon, that is, this is ethane. Ethane is the hydrocarbon with 2 carbon atoms. Methane, compound with 1 carbon. Only the meth prefix you can found only in the saturated hydrocarbon. Meth means exam. Name compound. And this is another example, ethane. Ethane in the sense. And this is the example for unsaturated hydrocarbon. Unsaturated hydrocarbon in the sense they may have double bond or triple bond. Element, carbon element combines with hydrogen element to form hydrocarbon, to form single bond, double bond and triple bond. If it is only single bond, then you can call it as saturated. Here the pair of electrons undergoing covalent bond to form double bond, hence it is unsaturated. I already told unsaturated hydrocarbons has double bond and triple bond, hence this ethene belongs to unsaturated hydrocarbon. Okay, now how to name saturated hydrocarbons. What are saturated hydrocarbons? Hydrocarbons with single bond. Okay, now how to name it? We should name with the prefix. So if it is meth, there is only 1 hydrocarbon. If there is 2 carbon, then you should call them as eth. If it is 2, it is eth. Then suffix, look at suffix ane. Ane is common for saturated hydrocarbons. Ane is the suffix. Meth, eth, prop, but, pent, hexa, hepta, octa, nona, deca. These are the prefixes. Okay. Always the prefix, if it ends with suffix ane. ಯಾವುದೇ hydrocarbon prefix meth, eth, prop, but, pent, hexa, hepta, octa, nona, deca ಈ ಹೆಸರುಗಳಿಂದ ಪಡ್ಕೊಂಡಿದ್ರೆ it gives the name of the hydrocarbon. ಅದೇನೇನು ಸುತ್ತೆ ಹೈಡ್ರೋಕಾರ್ಬನ್ ನಲ್ಲಿ ಕಾರ್ಬನ್ ಎಷ್ಟಿದೆ ಅಂತ ಹೇಳುತ್ತೆ. ಮೆತ್ ಅಂದರೆ ಎಷ್ಟು ಕಾರ್ಬನ್ನು? 1. ಎತ್ ಅಂದರೆ 2. ಪ್ರೋಪ್ ಅಂದರೆ 3 ಕಾರ್ಬನನ್ನು ಹೊಂದಿದೆ. ಬ್ಯೂಟ್ ಅಂದರೆ 4 ಕಾರ್ಬನನ್ನು ಹೊಂದಿದೆ. ಪೆಂಟ್ ಅಂದರೆ 5 ಕಾರ್ಬನನ್ನು ಹೊಂದಿದೆ. ಎಕ್ಸಾ ಅಂದರೆ 6, ಹೆಪ್ಟಾ ಅಂದರೆ 7, ಆಕ್ಟಾ ಅಂದರೆ 8, ನನ ಅಂದರೆ 9, ಡೆಕಾ ಅಂದರೆ 10. ಏನನ್ನು ಸೂಚಿಸುತ್ತೆ? ಪ್ರಿಫಿಕ್ಸ್ ಏನನ್ನು ಸೂಚಿಸುತ್ತೆ? ಹೈಡ್ರೋಕಾರ್ಬನ್ನಲ್ಲಿ ಕಾರ್ಬನ್ ಎಷ್ಟು ಅಂತ ಸೂಚಿಸುತ್ತೆ. ರೈಟ್? Now what does the prefixes indicates? The prefixes indicates the number of carbon in an hydrocarbon. Okay? Meth in the sense 1 carbon, eth 2, prop 3, but 4, penta 5, hexa 6, hepta 7 carbon, octa 8 carbon, nana 9 carbon, deca 10 carbon. Okay? Now how to fill the hydrogen? ಈಗ ಕಾರ್ಬನ್ ಏನೋ ಗೊತ್ತಾಯಿತು. ಈಗ how to fill hydrogen? Now start writing the carbon elements and then give the single bond with hydrogen. Then it completes structure. Now look at first example. You write first 1 carbon, then fill single bond. Now each carbon should have 4 bonds. Count the bonds. It should have how many bonds? 4 bonds. ನಾವು ಸ್ಟ್ರಕ್ಚರ್ ಬರೆಯುವಾಗ ಏನನ್ನು ನೋಡಬೇಕು ಮುಖ್ಯವಾಗಿ ಅಂತಂದರೆ, ಒಂದು ಕಾರ್ಬನ್ಗೆ 4 ಬಾಂಡ್ ಇದೆಯಾ ಇಲ್ವಾ ಅಂತ ನೋಡಬೇಕು. ಒಂದು ಕಾರ್ಬನ್ಗೆ ಎಷ್ಟು ಬಾಂಡ್ ಇರಬೇಕು? 4 ಬಾಂಡ್ ಇರಬೇಕು. ಅದನ್ನು ಕೌಂಟ್ ಮಾಡಬೇಕು. ಆವಾಗ ಸ್ಟ್ರಕ್ಚರ್ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ ಅಂತ ನಿಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಈಗ ಫಸ್ಟ್ ಎಕ್ಸಾಂಪಲಿ ಒಂದು ಕಾರ್ಬನ್ಗೆ ಎಷ್ಟು ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಇದೆ? 4 ಇದೆ. ಅಂದರೆ ಒಂದು ಕಾರ್ಬನ್ಗೆ ಎಷ್ಟು ಬಾಂಡ್ ಇರಬೇಕು? 4 ಬಾಂಡ್ ಇರಬೇಕು. ಈಗ ಸೆಕೆಂಡ್ ಎಕ್ಸಾಂಪಲ್ಗೆ ಹೋಗೋಣ. ಈಥೇನ್. ಎತ್ತಿದ್ರೆ ಎಷ್ಟು ಕಾರ್ಬನ್ ಇರಬೇಕು? 2 ಕಾರ್ಬನ್. ಯು ಜಸ್ಟ್ ರೈಟ್ 2 ಕಾರ್ಬನ್ಸ್. ಓಕೆ? ದೆನ್ ಯು ವಾಂಟ್ ಟು ಕಂಪ್ಲೀಟ್ ಬಾಂಡ್ಸ್ ಫಾರ್ ಬೋತ್ ದ ಕಾರ್ಬನ್ ಆಟಮ್. 2 ಕಾರ್ಬನ್ಗೆ ನೀವು ಬಾಂಡ್ ಕಂಪ್ಲೀಟಾಗಿ ನೋಡ್ಕೋಬೇಕು. ಈಗ ನೋಡಿ, ಫಸ್ಟ್ ಈಥೇನಲ್ಲಿ ಫಸ್ಟ್ ಕಾರ್ಬನ್ಗೆ ಎಷ್ಟು ಬಾಂಡ್ ಇದೆ? 3 ಹೈಡ್ರೋಜನ್ ಇದೆ, 3 ಬಾಂಡ್ ಆಯಿತು. ಒಂದು ಕಾರ್ಬನ್ ಜೊತೆ ಇದೆ, ಅದು ಒಂದು ಬಾಂಡ್ ಲೆಕ್ಕ. ಸೊ ಎಷ್ಟು ಬಾಂಡ್ ಆಯಿತು? 4 ಬಾಂಡ್ಸ್ ಆಯಿತು. ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ಗೆ ಬನ್ನಿರಿ. ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ಗೆ ಬಂದಾಗ 3 ಹೈಡ್ರೋಜನ್ ಇದೆ ಮತ್ತು ಒಂದು ಕಾರ್ಬನ್ ಜೊತೆ ಜಾಯ್ನ್ ಆಗಿದೆ. ಸೊ ಎಷ್ಟಾಯಿತು? ಈ ಕಾರ್ಬನ್ಗೂ 4 ಬಾಂಡ್ಸ್ ಆಯಿತು. ಬಟ್ ಲೆಕ್ಕ ನೋಡಿದಾಗ ಕಾರ್ಬನ್ ಟು ಕಾರ್ಬನ್ ಇಟ್ ಈಸ್ ಶೇರಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ರೈಟ್? Carbon to hydrogen, even there they are sharing the electron. So ಎಲ್ಲ ಬಾಂಡು ಶೇರ್ ಆಗಿ ಅಲ್ಲಿ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗಿದೆ. ಸೊ ಈ ಥರ ನಾವು ಕಂಪ್ಲೀಟಾಗಿ ಒಂದು ಕಾರ್ಬನ್ಗೆ 4 ಬಾಂಡ್ಸ್ ಇದೆಯಾ ಅಂತ ಚೆಕ್ ಮಾಡಿದಾಗ ಆವಾಗ ನಿಮ್ಮ ಸ್ಟ್ರಕ್ಚರ್ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ರಾಂಗ್ ಆಗಲ್ಲ. ನೀವು ಹೈಡ್ರೋಕಾರ್ಬನ್ ಸ್ಟ್ರಕ್ಚರ್ ಏನು ಬರೀತೀರ ಪರ್ಫೆಕ್ಟಾಗಿ ಬರುತ್ತೆ. ಓನ್ಲಿ ಬೈ ಕೌಂಟಿಂಗ್ ದ ಬಾಂಡ್ಸ್ makes the complete structure. Okay? Ethane. Now first methane, CH4. Ethane, C2H6. Propane, C3H8. Alva? Now how to get this molecular formula? ಹೇಗೆ ಪಡ್ಕೋಬೋದು ನಾವು ಇದನ್ನು? by the general formula called CnH2n plus 2. CnH2n plus 2. CnH2n plus 2 is the general formula for saturated hydrocarbon. Now, ಈ ಫಾರ್ಮುಲಾ ಹಾಕ್ಕೊಂಡು ನೀವು ಮೀಥೇನಲ್ಲಿ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ನಿಮಗೆ ಸಿಗಬೇಕು ಅಂದರೆ ಏನು ಮಾಡಬೇಕು? CnH2n plus 2 ಫಾರ್ಮುಲಾ ಹಾಕ್ಕೊಳ್ಳಿ. ವಾಟ್ ಈಸ್ ದ ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್ ಇನ್ ಮೀಥೇನ್? 1. ಹಾಗಾದರೆ C1H2 into 1 plus 2 ಹಾಕ್ಕೊಳ್ರಿ. C1 ಅಂದರೆ ಸಿ ಅಂತಾನೆ, ಅದಕ್ಕೆ ನಂಬರ್ ಇರಲ್ಲ. 1ಗೆ ನಾವೇನು ಬರೆಯಲ್ಲ. C1 ಅಂದರೆ ಸಿ ಅಷ್ಟೆ. ಈಗ ಹೆಚ್ ಹತ್ರ ಬನ್ನಿರಿ. ಫಾರ್ಮುಲಾ ಹಾಕ್ಕೊಂಡು ಬಂದಾಗ ಏನಾಗುತ್ತೆ? 2 into 1, 2 1s are 2 plus 2. 2 plus 2 ಏನಾಯಿತು? 4. So what is the formula for methane? CH4. Clear? ಹಾಗೆಯೇ ಎಲ್ಲಾನು ಈಗ ಮೆತ್ತಿಂದ ಡೆಕೇನ್ವರೆಗೂ ಸ್ಯಾಚುರೇಟೆಡ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ ಫಾರ್ಮುಲಾಸ್ನ ಬರ್ಕೊಂಡು ಅಸೈನ್ಮೆಂಟು ಹೋಮ್ವರ್ಕ್ ಮಾಡ್ಕೊಂಡು ಬರಬೇಕು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ. ಓಕೆ, ಫ್ರಮ್ ಮೀಥೇನ್ ಟು ಡೆಕೇನ್. Okay, Meghana, so late. Okay, now I hope everybody cleared how to write the structure for saturated hydrocarbon. Right? Cleared? Should I repeat? Will you write all the structures from methane to decane? Will you submit me tomorrow? Okay, fine. Okay, fine. If it is cleared, now the general formula for saturated hydrocarbon is CnH2n plus 2. Now you want to write the structures and molecular formula for saturated hydrocarbons from methane to decane. You want to submit me tomorrow. Okay, fine, all of you. Okay, now we'll move on to the unsaturated hydrocarbons. Now what are unsaturated hydrocarbons? The unsaturated hydrocarbons are the hydrocarbons with double and triple bond. They easily undergo addition reaction. By breaking the double bond and triple bond, they undergo addition reaction. They are less reactive and they are less stable compared to the saturated hydrocarbons because they can easily break their bonds and they can combine with other elements. Unsaturated are less reactive because they can easily broken down their bonds and they can combine with other elements by the process called addition reaction. Okay, now I'll share the screen. Okay, after methane, 1 carbon, 2 carbon hydrocarbon is ethane, 3 carbon is propane. Now you just look at some more example. Butane with 4 carbon atom, pentane with 5, hexane with 6. Okay, now hydrocarbons can represented in different way. Now look at first example. The butane is written in a long chain. The first example, it is written in a long chain. The second one is same. The second one is also butane. The second one is also butane, but it is branched. The second one is branched. The first one is long chain of hydrocarbon. Second one is branched chain of hydrocarbon. When you look at the carbon and hydrogen number, it is same. You just count in first one 4 carbon and 10 hydrogen. You look at second example, 4 carbon and 10 hydrogen, right? Now what are these compounds called as? Having same molecular formula, that is C4H10 in both the cases. C4H10 is the molecular formula in both the examples, but the structure is different. The structure is entirely different. What are these compounds called as? This is very important for board exam. Okay, now I give the example C4H10. They are written in two different ways, but having same molecular formula. Very good, Priyanka. They are called isomers. And what is the phenomenon called as? What is the phenomenon called as? Yeah, Nandita, they are called isomers. Fine. Yeah, Varalakshmi, isomerism is the phenomenon. The phenomena is isomerism and the compounds are called isomers. Okay. Isomerism is a phenomena where the isomers show different structures but have same molecular formula. The compounds having same molecular formula but different structures are called isomers, and the phenomenon is called isomerism. Okay, this is very important for your board exam. What are isomers? What is isomerism? These are the common questions you can find in your board exam. The compounds having same molecular formula but different structural formula are called isomers, and the phenomenon is known as isomerism. Okay, fine. All of you cleared? Okay. If it is clear, shall we move on to the next concept? Okay, fine. Now, we come to know the hydrocarbons can be represented as long chain, branched chain, and even we can represent them in a closed structures. Even it can be represented as a closed structure. Okay, now look at this example. The methane and ethane differs by CH2. Ethane and propane, again it is differed by CH2. Butane and pentane, again it is differed by CH2. And this is called homologous series. The hydrocarbons where the elements differ by CH2 and they have general formula, then it is called homologous series. Any compounds which they differ by CH2 and they have general formula are called homologous series. And this is the example for homologous series. Each compound from the other compound differs by CH2. Hence, they are called homologous series. Now, saturated hydrocarbons are called alkanes. Unsaturated hydrocarbons called as alkenes and alkynes. Alkanes have only one bond. Alkenes have double bond. Alkynes have triple bond. Alkanes have single bond. Alkene, ene. The suffix ene indicates double bond. The suffix ane indicates single bond. The suffix yne at the last indicates triple bond. What are the difference between alkenes, alkenes and alkynes? Alkanes have CnH2n plus 2 general formula. Alkene CnH2n. Alkyne CnH2n minus 2. Alkanes are less reactive, highly stable. Alkenes are not so active compared to the alkanes, as they are made up of double bond, easily broken down, and other elements can be added here. Alkynes are most reactive because they have triple bond, easily broken down, and more elements can be added here. Hence, they are more reactive. Alkanes are less reactive. Alkenes are most reactive. Alkynes are more reactive. Alkanes undergo substitution reaction but not addition reaction. Alkanes undergo substitution reaction but not addition reaction. Alkenes and alkynes, they easily undergo addition reaction. Addition reaction in the sense addition of hydrogen. The double bond can be broken down and hydrogen can be added. Triple bond can be broken down and hydrogen can be added. But alkanes, no bond can be broken down because it is made up of single bond. So no chance for addition reaction among the alkanes. So they undergo substitution. They easily replace but not addition. Okay, all of you give me the general formula for alkanes, alkenes and alkynes. I'll just be back within 2 minutes. All of you type the answer. General formula for alkanes, alkenes and alkynes. Okay. Sandhya formula is completely wrong. Where is plus? CnH2n plus 2 is for alkenes, right? Sandhya, you check your answer. Okay, Suresh Reddy is correct answer. Okay, Kirti, later you can go with the link. Okay, if you have problem, you can go with the link. Very good, Venuka. Venuka has improved a lot. Yes, Ashita correct. And even under name Mala is correct. Nandita, Deepa correct answers. Kushwant Reddy plus 2 is missing. Plus, you just type plus, but you missed 2. Okay, Shubha, molecular formula is correct. But what you wrote for alkyne, Alkyne is wrong. The word is wrong. Yeah, Aishwarya, correct. Your answer is correct. Varalakshmi, CnH2n. There you want to write small n, not capital N. Okay. And Priyanka answer is correct. And not audible in the sense I was not speaking since from 5 minutes. Okay, it's not network problem. I just took a 5 minutes break. Okay. Okay, now till now we studied a long chain structure and branched structure. Okay, and we have another category called closed structures. What are these closed structures called? And the closed structures with single bond are called cycloalkanes. Cycloalkanes are the alkanes with single bond, but when there is a cyclo, that means they are closed structures. They are showing closed structures. Okay. And there is another compound, that is benzene. Benzene is considered to be aromatic hydrocarbon because of its aroma, and it is entirely different. They have double bond. Okay. Cycloalkanes has single bond. The benzene structure has double bond. You just go with the benzene structure and cycloalkanes, and they may ask for exam. Okay. Okay, Sandhya, but blunder mistake. What you did is blunder mistake because the structures is entirely wrong. Now look the structure, Sandhya. CnH2n minus. Where minus comes for alkanes, that is wrong. Alkanes is correct. Alkynes is correct. Okay. Alkanes is wrong. Okay, it happens. It happens, Shubha. Sandhya, okay, no problem. When you write on the paper, don't do the mistakes. Okay, while typing, it happens. Okay, in hurry burry, it will happen. But when you write on the paper, don't do such mistakes. Okay, now I'll share the screen. We'll go with other concepts. Now, tomorrow assignment, this is the assignment for you all. You want to write the name of the hydrocarbon, then molecular formula, then structural formula. For alkanes, I already gave, but now you want to go again with alkenes and alkynes because you have plenty of time today. You can go with alkenes and alkynes. Now, this is the structures for alkenes. Always the alkene starts from ethene. Till decene you want to write the structure. Okay. Now, wherever you go with double bond, observe the first carbon will have only 2 hydrogen. The second carbon will have only 1 hydrogen. Remember, wherever you write double bond, the first carbon will have only 2 hydrogen. The second carbon will have 1 hydrogen. If you have this concept, then you don't do any mistake. This is also for alkenes. This is also for alkenes. And this is alkanes. Okay, there is no Okay, I didn't download it for alkyne. Alkyne, even alkyne is also stands from ethine. Eth, it stands from eth, ethine. There is no meth in alkene and alkyne. Why? Why there is no meth in alkene and alkyne? Because in order to undergo double bond and triple bond, minimum they need 2 carbon. Minimum they need 2 carbon. Hence, there is no meth in alkenes and alkynes. Okay. Now, what is the basic principles to be followed while naming the hydrocarbons? First step, identify the number of carbon atom. Give the prefix. Give the prefix. Okay. Name the functional group and then give it as a suffix. Give it as a suffix. Example, for alcohol, OL all is added at the last. For aldehyde, NAL, AL is added at the last. Okay, these are the functional groups given at the last. Okay, first thing is identify the number of carbon atom, give the prefix, that is meth, eth, prop, but, hept, etc. Look at the functional group, whether it is alcohol, give at suffix, give at last. The last. Carboxylic acid, oic acid, OIC, oic acid at the last. Okay, for alkenes, ENE at the last. For alkanes, ANE at the last. For alkynes, YNE at the last. Okay. Okay, first you want to give the carbon number and then identify the functional group and then give the functional group at the suffix. Okay, and you want to see whether the given compound is saturated or unsaturated. If it is saturated, ANA is the last. If it is saturated, ANA is the last. If it is unsaturated, double bond, then ENE. Unsaturated, triple bond, then YNE. Okay. Okay, now how to nomenclature the carbon compounds. Yes, we had a deep discussion. Now all the functional groups will be given as suffix except one, which is that ಎಲ್ಲ ಸಫಿಕ್ಸಸ್ ಅಲ್ಲೂ ನಾವು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪನ್ನು ಸೇರಿಸ್ತೀವಿ. ಒಂದನ್ನು ಹೊರತುಪಡಿಸಿ ಯಾವುದನ್ನು ಬಿಟ್ಟು ನಾವು ಎಲ್ಲ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪನ್ನು ಸಫಿಕ್ಸ್ ಕೊಡ್ತೀವಿ. ಒಂದನ್ನು ಮಾತ್ರ ನಾವು ಸಫಿಕ್ಸ್ ಕೊಡಲ್ಲ. ಯಾವುದದು? which is only one we won't give the functional group as suffix, which is that the answer is quite simple. It is haloalkanes. Halo means halogens. If the functional group is halogens, then you won't give it as suffix. Last al kodak hogbardu. Then where to give? It is given at the beginning. Example, yes, alkanes. Okay, correct, Priyanka. Now, which is that? Now propane with chlorine. Now how to mention? Chloropropane. Now propane with bromine. How to mention it? Bromopropane. Means the functional group is given first only in the haloalkanes and rest of the things are at the suffix. Okay, clear? Very ಹ್ಯಾಲೋ ಆಲ್ಕೆನ್ಸಲ್ಲಿ ಮಾತ್ರ ಹೆಸರು ಮೊದಲು ಕೊಡಲಾಗುತ್ತೆ. ಇನ್ನು ಉಳಿದ ಆಲ್ಕೋಹಾಲ್, ಆಲ್ಡಿಹೈಡ್, ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆ್ಯಸಿಡ್ಸ್, ಕೀಟೋನ್ಸ್, ಅಮೈನ್ಸ್ ಇವೆಲ್ಲ ನಾವು ಎಲ್ಲಿ ಮಾಡ್ತೀವಿ? ಕೊನೆಗೆ ಮಾಡ್ತೀವಿ. ಹೇಗೆ? ಬೈ ಸಫಿಕ್ಸ್ ಹೇಗೆ? ಇಟ್ ಇಸ್ ಫಿಕ್ಸ್ಡ್ ಫಾರ್ ಆಲ್ಕೋಹಾಲ್. ವಾಟ್ ಈಸ್ ದ ಸಫಿಕ್ಸ್ ಫಾರ್ ಆಲ್ಕೋಹಾಲ್? ಎಸ್, ಕಮಾನ್. What is the suffix for alcohol? I didn't get any reply. What is the suffix for alcohol? Just suffix. ಕೊನೆಯಲ್ಲಿ ಬರೆಯೋದನ್ನ ಸಫಿಕ್ಸ್ ಅಂತೀವಿ, ಮೊದಲು ಬರೆಯೋದನ್ನ ಪ್ರಿಫಿಕ್ಸ್ ಅಂತೀವಿ. ಯಾ, ಪ್ರಿಯಾಂಕಾ and Varalakshmi correct. OL. Yes, all of you answering correctly. OL is the suffix for alcohol. Okay, now what is the suffix for aldehyde? What is the suffix for aldehyde? Okay, OL, all for alcohol, it's correct. What is the suffix for aldehyde? Yes, Priyanka, Nandita, Ishwarya, correct answers. Yes, Arshita. Shubha, you are giving us OL. OL is for alcohol, not for aldehyde. Yes, correct, Venuka. Okay. What is the suffix for double bond compounds? What is the suffix for double bond compounds? Al for aldehydes, it's correct. What is the suffix for double bond compounds? If there is double bond, then what is the suffix? Arpita went wrong. Why any? It is for ketone. I didn't ask. Yeah, Tanushree, correct for aldehydes. What is the suffix for double bond compounds? Hydrocarbons, double bond hydrocarbon. Yes, Priyanka, it's correct. ENE. Alkenes are double bond compounds, so suffix is ENE. Okay. Now what is the suffix for carboxylic acid? Okay, fine, all of you fine. What is the suffix for carboxylic acid? Yeah, Ishwarya, Deepa, Sandhya, Kushwant Reddy, I've forgotten the name. It's correct. Now, what is the functional group for carboxylic acid? Yes, oic acid. Correct, Priyanka. Oic acid. Yeah, Deepa, Nandita, correct. Arpita, correct. Tanushri, Varalakshmi, Kushwant Reddy and Shubha. Everyone responded correctly. Now, what is, yes, Vidya, Venuka, correct? Now, what is the suffix for triple bond hydrocarbon? What is the suffix for triple bond hydrocarbon? Okay, Tanuja. Okay, fine. Yes, it's correct, Priyanka. YNE. Yes, YN is the correct answer. All of you responding correctly. And what is the functional suffix for functional group ketone? What is the suffix for functional group ketone? For ketone. Yes, it's correct, Priyanka. ONE. On. Yes, for Lakshmi, Nandita, correct answers. Yeah, Arpita, Tanushri, Shubha, Aishwarya, Tanuja. Yes, all of you correctly responded. Yes, Vidya and Sandhya. And Deepa. Okay, fine. Okay, fine. Now, we'll move on to the next concept. That is closed structures. Which were the closed structures? As a prefix. Alcohol at the last, OL. Aldehyde, AL at the last. Hence they are called suffix. Ketone, ONE, where you give at the last. Propanone. Carboxylic acid, oic acid at the last. Propanoic acid. ENE at the last. Propene. YNE at the last. Propine. So here everywhere we'll give it as a suffix except haloalkanes. Okay, I just don't have the structure of benzene. Okay, you can look at in your study material page number 9 and 8. Look at page number 8 and 4.9. Now there is an 6 carbon closed structure and it is having single bond with 4 valence electron with each and every carbon atom, and that is called cyclohexane. It is called as cyclohexane, and this cycloalkane starts from propane, cyclopropane, because it requires minimum 3 points to close the structures. The cycloalkane starts from cyclopropane. The starting element is cyclopropane, minimum 3 points, 3 carbon to close the structure. And cyclopropane, cyclobutane, cyclopentane, cyclohexane. Okay, and look at page number 9. Benzene. Write 6 ಒಂದನ್ನ you double benzene like ಸೈಕ್ಲೋಹೆಕ್ಸೇನ್ ಯಾವ ರೀತಿ 6 ಕಾರ್ಬನನ್ನು ಬರೀತಿರೋ ಅದೇ ರೀತಿ ಹುಕ್ ಬಂತ ಬಂದೆ in benzene 6 carbon, and even for cyclohexane 6 carbon, but the difference is cyclohexane single bond, but in the benzene it is having double bond at alternate position. Okay, the difference is cyclohexane alli ಸಿಂಗಲ್ ಬಾಂಡ್ ಇರುತ್ತೆ, ಒಂದು ಕಾರ್ಬನ್ಗೆ 2 ಹೈಡ್ರೋಜನ್ ಇರುತ್ತೆ. ಬೆನ್ಸಿನನ್ನು ನೋಡಿದಾಗ ಬೆನ್ಸಿನಲ್ಲೂ 6 ಕಾರ್ಬನ್ ಇದೆ. ಒಂದು ಕಾರ್ಬನ್ ಹೊರತುಪಡಿಸಿ ಇನ್ನೊಂದು ಕಾರ್ಬನ್ಗೆ ಡಬಲ್ ಬಾಂಡ್ ಕೊಡಬೇಕಾಗಿ ಬರುತ್ತೆ. ಡಬಲ್ ಬಾಂಡ್ ಕೊಟ್ಟ ಮೇಲೆ ಏನಾಗುತ್ತೆ, ಒಂದು ಹೈಡ್ರೋಜನ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಡಬಲ್ ಬಾಂಡ್ ಇಲ್ಲಿ 2 ಹೈಡ್ರೋಜನನ್ನು ಎಳ್ಕೊಂಡಂಗೆ, ಅಲ್ಲಿಂದ ಇಲ್ಲಿಂದ ಒಂದು ಹೈಡ್ರೋಜನನ್ನು ಎಳ್ಕೊಂಡಂಗೆ ಆಯಿತು. ಸೊ ಹಾಗಾಗಿ ಸಿಗೆ ಎಷ್ಟು ಕಾರ್ಬನ್ ಉಳಿಯುತ್ತೆ, ಸಿಗೆ ಎಷ್ಟು ಹೈಡ್ರೋಜನ್ ಉಳಿಯುತ್ತೆ, ಹೈಡ್ರೋಜನ್ 1 ಮಾತ್ರ ಉಳಿಯುತ್ತೆ. ಹಾಗಾಗಿ ಬೆನ್ಸಿನ್ಗೆ C6H6, ಸೈಕ್ಲೋಹೆಕ್ಸೇನ್ಗೆ C6H12. ಓಕೆ, ಬೋತ್ ದಿ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಯು ವಾಂಟ್ ಟು ಪ್ರಾಕ್ಟೀಸ್. ಸೈಕ್ಲೋಹೆಕ್ಸೇನ್ ಮತ್ತು ಬೆನ್ಸಿನ್ ಎರಡೂ ಸ್ಟ್ರಕ್ಚರ್ನ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ ಎಕ್ಸಾಮ್ಗೆ ಬರುತ್ತೆ. ಆ್ಯಂಡ್ ಇಸ್ ದೇರ್ ಎನಿ ಫಾರ್ಮುಲಾ ಫಾರ್ cycloalkanes? Yes, there is formula, that is CnH2n. cycloalkanes ಗೂ ಫಾರ್ಮುಲಾ ಇದೆ CnH2n. okay, and the chemical reaction is combustion. All hydrocarbons undergo combustion. Combustion in the sense the hydrocarbon and the carbon burn in presence of oxygen to release heat, light and energy. Heat, light and energy. Now look at first example. Carbon burns in oxygen to form carbon dioxide. Second example, methane burns in oxygen to form carbon dioxide and water. Third one, the ethanol burns in oxygen to form carbon dioxide, water plus heat and light. Okay, combustion is a process where oxidation takes place. And the next one is addition reaction. What is addition reaction? Now any saturated hydrocarbons with single bond are less reactive. Any unsaturated hydrocarbon with double bond or triple bond, they are more reactive. We come to know this just now in our previous discussion. Yella saturated hydrocarbons are less reactive because they are made up of single bond. No chance to take other elements. Whereas ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಅಲ್ಲಿ ಚಾನ್ಸ್ ಇದೆ, ಡಬಲ್ ಬಾಂಡ್ ಇದೆ, ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಇದೆ, ಅದು ಹೊಡೆದ್ರೆ ಬೇರೆ ಎಲಿಮೆಂಟ್ ಬಂದು ಜಾಯಿನ್ ಆಗ್ಬೋದು. ಹಾಗಾಗಿ ಸ್ಯಾಚುರೇಟೆಡ್ಗಿಂತ ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಏನಾಗುತ್ತೆ, ಅಡಿಷನ್ ರಿಯಾಕ್ಷನಲ್ಲಿ ಪಾಲ್ಗೊಳ್ಳುತ್ತೆ. ಸೊ ವಾಟ್ ಈಸ್ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್? ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ ಬೈ ಆ್ಯಡಿಂಗ್ ಹೈಡ್ರೋಜನ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ನಿಕಲ್ ಕೆಟಲಿಸ್ಟ್ ಕನ್ವರ್ಟ್ ಇಂಟು ಸ್ಯಾಚುರೇಟೆಡ್ ಫ್ಯಾಟ್ಸ್. ಐಲ್ ರಿಪೀಟ್, ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ತುಂಬ ಮುಖ್ಯ ಎಕ್ಸಾಮ್ಗೆ. ಇನ್ನೊಂದು ಬಾರಿ ಹೇಳ್ತೀನಿ. ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಆಯಿಲ್ in presence of hydrogen and nickel catalyst, it converts into saturated fats. ಏನಾಗುತ್ತೆ, ಸ್ಯಾಚುರೇಟೆಡ್ ಫ್ಯಾಟ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಇದನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ, ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್. ದಿಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. Okay, and look at page number 15, substitution reaction. Substitution reaction means replacement of the hydrogen with other functional group. ಹೈಡ್ರೋಕಾರ್ಬನ್ ಅಲ್ಲಿ ಒಂದು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಬಂದು ಸೇರಿಕೊಂಡ್ರೆ ಅದನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಟೆಕ್ಸ್ಟ್ ಬುಕ್ಕಲ್ಲಿ 15 ಪೇಜ್ ನಂಬರಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? ಮೀಥೇನ್ ಕಂಬೈನ್ಸ್ ವಿತ್ ಕ್ಲೋರಿನ್ ಟು ಫಾರ್ಮ್ ಟ್ರೈಕ್ಲೋರೋ, ಡೈಕ್ಲೋರೋ ಮೀಥೇನ್, ಟೆಟ್ರಾಕ್ಲೋರೋ ಮೀಥೇನ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಸನ್ಲೈಟ್. ಇದನ್ನು ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಎಥೆನಾಲ್ ಎಥನೋಯಿಕ್ ಆ್ಯಸಿಡ್ ಹ್ಯಾಸ್ ಬಿನ್ ಡಿಲೀಟೆಡ್. ಈ ಕಾನ್ಸೆಪ್ಟನ್ನು ತೆಗೆದಾಕಿದ್ದಾರೆ, ನಿಮಗೆ ಎಕ್ಸಾಮ್ಗೆ ಬರೋದಿಲ್ಲ. ನಿಮಗೆ ಕೊನೆಗೆ ಸೋಪ್ಸ್ ಆ್ಯಂಡ್ ಡಿಟರ್ಜೆಂಟ್ಸ್. ಸೊ ಸೋಪ್ಸ್ ಆ್ಯಂಡ್ ಡಿಟರ್ಜೆಂಟ್ಸ್ ಐ ವಿಲ್ ಡಿಸ್ಕಸ್ ಇನ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್. ಓಕೆ, so almost chapter is completed except soaps and detergents. Ethanol and ethanoic acid has been removed, okay, this time for your examination. So almost we completed this chapter. Soaps and detergent matra ide, adu simple agide, we'll discuss later. Now thanks one and all, thanks for the visit and participation and also for active responding. Thank you. See you soon at the weekend, next weekend. Bye.